Howdy AP PreCal, it's Miss Kosh. I wanted to follow up on the video I had made for 3.7. So first of all, I think in my previous video I was a little confused about why it was this equation that starts at 0. And then I realized later they want a sinusoidal function used to model the x-coordinate. Okay, so as it's not so much yeah, anyway, it's where will the x-coordinate be, and then as you move around, that kind of stuff. And so then it gets more positive. When it gets out to here, it becomes less positive. It gets back to 0 here. Can you see both of my hands? Okay. And then it becomes negative, and then it gets back here. So I was a little, I knew I had the right equation. I just didn't understand why it would be shaped like that, but it was in particular the x-coordinate. All right. The other thing that I wanted to clarify from the last video was this problem when it came from the modeling problem. They talk about 16 iterations. Now, I don't know if this is going to be something that AP is going to ask you to do or not. I think I have a lot of respect for Mr. Passwater, but I haven't seen that so far in the AP world, but that doesn't mean anything. So, but I did figure out, one of my colleagues and a former student of mine helped me understand this one a little bit better. And that is that we're going to put 16 iterations means that we have the data set happens 16 times. Okay, so we had 8 pieces of data, and if that happens 16 times, what is it? 8 times 8 is 64 times 2 is 128. We would actually have 128 pieces of data in here. And so what my colleague suggested is, okay, so then the next one would be, we'd add 12 to each of these. So 12 plus 6 is 18, this is 19, this is 12 is 20. 11 plus 12 is 23, 12 plus 12 is 24. So that would be the next iteration. And so I'd have 13, 15, where am I, 16, oh, not 161. 18, 19, 20, 23. I still have the same data set from before, I think. And let's verify. So it was 11.4, 9.7, 8.2, 5.2, 5, 6.2, 10.5, 11.3, and then we would do it again. 11.4, 9.7, 8.2, 5.2, 5, 6.2, 10.5, and this is why I don't think AP would ask us to do this, because it just kind of gets to be a tedious data entry problem. And if you had Excel or maybe even Desmos where you could copy and paste, it would be more reasonable, but you can't quite do that. Or if you can do it in the calculator, I don't know how. So comment below if you do know how to do this in the calculator. I can graph this. Here's that. I can calculate. Let's see how it does with the sign regression. Okay, and so the question was about which value? Sinusoidal, what is the maximum number of nighttime hours predicted? Okay, so if I copy this, okay, this is probably that previous one. Let's copy it into Y2 and see if I draw that. Okay, here's that lovely curve. Then I can come back, I can go menu, and when I look at the graphs, let's now turn on both of these. So the new one is going to be in red that we just graphed, and it does seem a little different than the previous equation. So there was our first graph. Here's the second one, and so as we have more iterations, the data, the graph perhaps gets more accurate or less accurate. I don't know. Anyway, so we can G-solve, find the maximum value. We don't want the blue one. We want the red one. So here we go. Enter. And that maximum value, is that what they asked? What is the maximum number of nighttime hours predicted by the sinusoidal function? Okay, so now we're at 11.95, which doesn't happen either. Let's check the other one. G-solve, if I did the max of that first one, this was the 11.33, okay, which didn't match what we got. So then the new one had 11.55, which was bigger, but not an answer on here. So let's see, if we go back, I think we have to do another iteration. So let's see, if I add 24 now to each of these, I'm at 25. I'm at 24 plus 27, 28. 24, that's 30. Then I have 24 plus, that's 31. That's one higher. That's another higher. This is 3 higher, so that's 35. Anyway, 36. Okay, so if we get another, oh, you couldn't see what I was doing. My apologies. We come down and we have 25, we have 27, we have 28, we have 30, we have 31, we have 32, we have 35, we have 36. We come back in and enter our Y values again, 11.4. Hopefully, if you catch me make a mistake, comment below. I'm not sure how much I care, to be honest. But I'm good, but I'm not perfect. Okay, so now if I graph this, okay, calculate, we're going to do that sine regression. Okay, let's copy this. We're going to take it into Y3 now. Okay, here's that graph. If I come back out to my graph, let's turn on, well, we'll turn this one on first. Oop, exit. We'll come down here. We'll select. I will draw. Okay, we can tell they're not quite the same. I can't tell. That may be pretty close to the red. It's a little hard to tell. Let's go back out for just a second. Let's turn off these other two. Select. So I just am looking at this one. I just was lazy and didn't want to have to scroll down. When I do G solve max, there's only one equation to give me. Okay, so this is 11.6. So that's growing from where we were before. Weren't we at 11.5? To be honest with you guys, I'm not quite sure, but I think that's a little bit of what they're looking for. We will find out. I can't, to be honest with you, imagine that they're going to ask you to do, so far I've only done 3 iterations and the maximum grew each time. So it seems to have passed. I think that the answer would have been 11.4. What I'm planning on doing is reaching out in the Facebook group for PreCal teachers and see what other people have done and come up with, and we'll see if there's any discussion on this type of problem. If so, I may comment below. I may not. I may just say good luck, everybody. In any case, reach out, but don't forget to subscribe and keep watching my videos. All right, enjoy.